Hi everybody, today let's look at how to find the inverse matrix of a 2 by 2 matrix. Inverse matrix can only exist for square matrices, but not all square matrices have inverse matrices. Okay, if I have a matrix A with the element of A, B, C, D, we can represent the inverse matrix of this matrix using this notation, A with a -1 in superscript. The inverse matrix of A is equal to 1 over A times D minus B times C. And for this part, we change their places, interchange their places. D go up here, A go down. And these two, we change their sign. It means that if this is positive, it will become negative. If this is negative, it will become positive. This is the formula that we can use to find the inverse matrix. Okay, you will see this notation for inverse matrix is A with a -1 in superscript, right? But you don't get confused with this one. If I give you 3 raised to the power of -2, you know this is 1 over 3 to the power of 2, right? This is not the same case. We cannot assume that the inverse matrix is 1 over A, B, C, D like this. This is not correct. This -1 in superscript is just a notation for an inverse matrix. Okay? This part, AD minus BC, is the determinant. We call it determinant. This is the determinant of a matrix. We can represent this way or this way. DET, parentheses A. When this determinant is equal to 0, it will become 1 over 0, right? When 1 over 0, you calculate, you know this is undefined. That is why when the determinant of a 2 by 2 matrix is equal to 0, the matrix does not have an inverse matrix. Okay, you look at here. If the determinant AD minus BC is equal to 0, the inverse matrix of matrix A does not exist. Okay, so if the question asks you whether a given matrix has an inverse matrix, you just find its determinant. If its determinant is equal to 0, then the matrix does not have an inverse matrix. Okay, now let's look at a few examples. Okay, just now I forgot to tell you this. If I have a matrix A and the inverse matrix of matrix A, we can represent this way, right? I told you just now. A multiplied by A inverse is actually equal to A inverse multiplied by A, which will give you identity matrix. Okay, later on let's try to do the multiplication between the matrix and its inverse matrix. You will notice that every time you will get identity matrix back. Okay, now let's look at this example. By using the inverse formula, find the inverse of the following matrices if it exists. If it does not exist, state a reason. Okay, still remember, when the determinant is equal to 0, the inverse matrix does not exist. Okay, now let's find the determinant for matrix A first. We can represent it this way for the determinant. But don't get confused, this is not modulus A. When you get a negative number, right, let's say after you calculate the determinant, you get a negative number, you still need to keep the negative. You cannot, some students think this way, okay, this is modulus, so if I get -3, I change become 3. No, if you get -3, you still need to write -3. Okay, this is just the notation for determinant. Okay, still remember how do we find the determinants? This times this, 1 times -4 minus 3 times negative 2. AD minus BC, right? Okay, so this will give you negative 4 and this is positive 6. The determinant is equal to 2. Okay, since the determinant of matrix A is not equal to 0, then we know that matrix A has an inverse matrix. 1 over determinant of matrix A, which is equal to 2. And these two, we change their position, interchange their position. Negative 4 go up here, 1 go down. Negative 4 go up, 1 go down. And these two elements, we change their sign. This positive change become negative. Negative change become positive. Okay, next we just multiply the fraction over here, 1 over 3 into with the every element here. 1 over 2 times negative 4, 1 over 2 times negative 3, 1 over 2 times 2, and 1 over 2 times 1. Okay, so you should be able to get negative 2, and this is negative 3 over 2. This time this you will get 1, and this time 1 you will get 1 over 2. This is the inverse matrix of matrix A. You can actually use your calculator to help you to get the inverse matrix. Okay, this is the way. Press this menu here, then search for matrix equal. Okay, we are going to define a matrix. Matrix A, press 1. The calculator will ask you how many rows. We have 2 rows. How many columns? We have 2 columns. Okay, then we can start to key in all the elements here. 1, 3, negative 2, negative 4. 1, 3, negative 2, negative 4. Okay, now the calculator already remember this matrix. Press Options, then go for Matrix Calculations. Okay, then press Option again. We want to call out the matrix A that we just key in just now. Okay, now we are looking for the inverse matrix, right? Press this, negative 1. You will see X raised to the power of negative 1. Press the button, press equal. Okay, this is the inverse matrix of matrix A. Let's check correct or not our answer. Negative 2, negative 1 over 1.5 is actually equal to negative 3 over 2. 1 and 0.5 equal to 1 over 2. Okay, our answer correct. So remember, this is the way how we find the inverse matrix. Now let's try part B. B is equal to 2, 4, 4, 8. So I want to test first whether this matrix has an inverse matrix. So how do we test? We find its determinant, right? 2 times 8, 2 times 8 minus 4 times 4. This will give you 16, and here also 16. Eventually you will get 0. The determinants of matrix B is equal to 0. That means matrix B does not have an inverse matrix. Okay, so we want to give our reason. Matrix B does not have an inverse matrix because its determinant is equal to 0. Okay, when the determinants of a 2 by 2 matrix is equal to 0, that matrix does not have an inverse matrix. Remember this. Okay, now let's try another example. Given that this is equal to 1001, this is identity, right? Still remember just now what I told you. A times A inverse is equal to A inverse multiplied by A, which will give you identity matrix, right? So when you look at this product, this multiplication will give you identity matrix. You know that one of the matrix must be the inverse matrix of the another one. So you can say this is the inverse matrix of this, or you also can go another way. This is the inverse matrix of this. So in this case, I will do it this way. Let A equal to this 5H 4 negative 2. Okay, and because this whole thing multiplied by A will give you identity matrix, then I know that this is actually the inverse matrix of A, right? Let me write this way. A inverse. This is A. Give you identity matrix. Okay, now I'm going to use the formula to help me to get the inverse matrix of matrix A. 1 over 5 times negative 2, you will get negative 10. Okay, minus H times 4, you will get 4H. This is a determinant of matrix A. Okay, then when we come to the parenthesis part, don't forget, interchange these two elements, their positions. Negative 2 go up, the 5 go down here. Okay, and these two elements, we change their sign. Positive, you will change, we change become negative. Positive, we change become negative. So this is the inverse matrix of A. Now we know that this is equal to this, right? Because both of them are the inverse matrix of matrix A. So we can write this way. 1 over negative 10, negative 4H, negative 2, negative H, negative 4, 5. This is equal to this. 1 over K, negative 2, 3, negative 4, 5. Then we compare both sides. We know that negative H is equal to 3, right? Okay, negative H, negative H. Negative H is equal to 3. So 3 is, H is equal to negative 3. Okay, now we got the answers, the value of H. Now we are going to find the K. This is equal to K, correct? Negative 10 minus 4H is equal to K. And we knew the value of H, which is equal to negative 3. Negative 10 minus 4 times negative 3 is equal to K. So K will be equal to negative 10. Negative negative will give you positive. Okay, so K is equal to 2. K is equal to 2. H is equal to negative 3. So this is the way how we solve this type of questions. Okay, let's try one more example. Given B is equal to 2, negative 3, negative 2, 4. We want to find the inverse matrix of B. Still remember the formula? 1 over 2 times 4, you will get 8, minus negative 3 times negative 2, you will get positive 6. Okay, so now we are going to swap their places for these two elements. 4 go up, 2 go down. And these two elements, we change their sign. Negative, it becomes positive. negative, it becomes positive. 1 over 2, 4, 2, 3, 2. And the last, one more step, we just bring the negative, the 1 over 2 inside here. Multiply every single element here by 1 over 2. 1 over 2 times 4, you will get 2. 1 over 2 times 3, you will get 3 over 2. 1 over 2 times 2, you will get 1. And here the same thing, you will get 1. Okay, so this is the inverse matrix of matrix B. Just now I told you that A times A inverse is equal to A inverse times A, right? Is equal to identity. How about now let's try. See whether we can get the identity matrix or not. This is B inverse. This is B. I want to double check whether my answer is correct. So I take this one, multiply by this one. If I get if I get identity matrix, I know my answer will be correct. Okay, so B. You can use this or this. How about I use this one? B inverse times B. So which is equal to 2, 1, 3 over 2, 1. Multiply by the matrix B, 2, negative 3, negative 2, 4. Okay, I hope that you still remember the process. How do we find how do we do the multiplication between two matrices? Draw a horizontal line for the first matrix and a vertical line for the second matrix. 2 times 2, you will get 4. 3 over 2 times negative 2, you will get negative 3. Okay. Now let's move to second column. First row, still the first row, but we go to second column. First row, second column. So we have to write over here, not here. 2 times negative 6, 2 times negative 3, you will get negative 6. Sorry. 3 over 2 times 4, you will get 6, positive 6. Now let's move to second row and first column. 1 times 2, you will get 2. 1 times negative 2, you get negative 2. Second row, second column. 1 times negative 3, you will get negative 3. 1 times 4, you will get 4. Okay. 4 minus 3, you will get 1. 2 minus 2, you get 0. Negative 6 plus 6, you get 0. Negative 3 plus 4, you will get 1. Identity matrix. So our answer is correct. So you can try on your own. B multiplied by B inverse. You still will get the same thing, identity matrix. Okay, now let's try the last part for this video. Given matrix C is equal to 3, 2, K, negative 4. Find the value of K if C does not have an inverse matrix. 3, 2, K, negative 4. If C does not have an inverse matrix, that means the determinants of C is equal to 0, right? How do we find the determinant? 3 times negative 4 minus 2 times K. We know this must be equal to 0 because the question tells us that this matrix C does not have an inverse matrix. 3 times negative 4, negative 12, negative 2K is equal to 0. Okay, so negative 12 is equal to 2K. So K is equal to negative 12 divided by 2, which is equal to negative 6. Okay, let me check whether my answer correct. Negatives. Okay, correct. So K is equal to negative 6. If you want to check by using your calculator, you can do it this way. So if you want to edit the matrix A that you have just keyed in just now, you can press Option, then go to Edit Matrix. Edit Matrix. If you want to let this as matrix B, also can. So just here I just show you how to edit a matrix. Matrix A. Okay. Oh, I think I need to press edit matrix first. Okay, then go to matrix A. This is a matrix that I just key in. Okay, I keyed just now. Now I'm going to change their element 3 to 3 to k. K is equal to -6. And the last element is -4. Okay, correct. Then go to option, matrix calculations. Then press option again. I want to call out the matrix A that I just key in. Now I want to find the inverse matrix. I know that this the calculator should not be able to give me the inverse matrix of this matrix because k is equal to -6 will make the determinant of this matrix become 0. That means this matrix does not have an inverse matrix, right? Okay, now press equal. You will get math error because this matrix does not have an inverse matrix. Okay, that's all for this video. I hope that you understand better after watching my video how to find the inverse matrix of a 2 by 2 matrix. See you next time. Thanks for watching. Bye bye.